Imagine a system that can write like an expert and still be completely wrong. It doesn't lie on purpose, it just sounds right. In the next few minutes, I'll show you exactly why that happens and how to spot it fast. Hey everyone, welcome back. Quick question before we start. Where are you watching from right now? What country or city? Drop it in the comments, I read them. Today, we're talking about something that tricks a lot of people. Why ChatGPT and similar tools can sound confident and polished, even when the answer is wrong. Here's the first thing to understand. The system isn't searching your question the way you do. It's generating a response one token at a time, choosing the next most likely word given the words before it. With enough training data, it becomes great at producing text that looks like a real explanation. Humans are wired to treat fluent language as a signal of competence. If the grammar is clean, the tone is calm, and the structure feels logical, our brains assume there must be solid reasoning underneath. That's why a smooth, step-by-step answer feels trustworthy, even when the steps are built on sand. Think of it like an actor playing a doctor on TV. The actor knows the lines, the posture, the vocabulary, and the rhythm of a medical explanation. To a casual viewer, it feels like expertise. But the actor doesn't actually diagnose anyone. They're performing the shape of knowledge. These tools also copy patterns that humans associate with serious answers, definitions, bullet points, numbered steps, and confident conclusions. Even phrases like "in summary" or "the key takeaway" act like psychological stamps of authority. That's the core illusion, language that resembles understanding. So when you read a confident paragraph, don't ask, "Does it sound smart?" Ask, "What would make this true?" Fluency is a style feature. Truth requires evidence, references, or a check you can reproduce. Now let's talk about why it sounds so confident. When a model answers, it's not double-checking reality in the background. It's optimizing for a response that fits the conversation, clear, coherent, helpful, and complete. And the safest way to sound helpful is to sound certain. That's why you often get strong statements, clean explanations, and a decisive tone, even in situations where a human expert would say, "It depends." In other words, confidence is often just the default presentation style. And here's the trap. Your brain doesn't evaluate confidence like a design choice. It interprets confidence as a signal of accuracy. If something is said smoothly, quickly, and with authority, we subconsciously lower our skepticism. The delivery becomes part of the evidence. This is why the same system can produce two different confident answers depending on small changes in wording. If you ask a vague question, it fills in the gaps. If you ask a leading question, it may follow your direction. If you ask for a definitive conclusion, it will often give you one, because that's what users usually reward with "this helped." So what should you do? Treat confidence like packaging. When the topic matters, force it to show its work. Ask for assumptions. Ask for uncertainty ranges. Ask for 2 to 3 alternative explanations. Ask, "What would make this answer wrong?" And if it's factual, ask for sources or a simple way to verify. Confidence can make an answer readable, but it doesn't make it true. Here's another reason it can sound right while being wrong. It doesn't remember facts the way humans do. A human can say, "I know this is true because I learned it, I saw it, I verified it, and I can trace where it came from." A model doesn't have that kind of memory inside the moment. It's generating the most likely next words based on patterns it has seen before. So if the internet has a common misconception, a repeated myth, or a popular but incorrect explanation, the model may reproduce it because it looks like the kind of answer people expect. And even when the correct information exists, it might be mixed with older or conflicting versions. The model can blend them into one smooth paragraph that sounds consistent, but is actually a stitched-together guess. That's why it sometimes invents details that feel reasonable. A date that sounds plausible, a quote that looks real, a study name that fits the topic, or a statistic that matches the vibe. These are the most dangerous errors because they don't look like obvious mistakes. They look like extra helpful context. This is also why it can't reliably tell you what happened yesterday or what changed last month unless it's connected to a live source. Without live verification, it's not retrieving reality, it's reconstructing something that resembles reality. The key takeaway is simple. The model's job is to produce a good-sounding answer, not to guarantee truth. If you want truth, you need a process that forces verification, sources, checks, and constraints. And when you do that, it becomes incredibly useful. But without that process, it can be confident and confidently wrong. One of the biggest traps is that confidence sounds like intelligence. When a person speaks confidently, we assume they know what they're talking about. Strong tone, smooth structure, no hesitation. Our brains interpret that as competence. And these models are built to speak smoothly. They rarely pause, they rarely say, "I'm not sure," and they can produce an answer instantly. But confidence here is mostly a style choice, not proof. The model will often pick one path and commit to it because a clear, direct answer is statistically more likely to match what people want. That makes the response feel decisive, even if the underlying guess is weak. Also, it doesn't experience embarrassment or doubt. Humans become cautious when we're unsure. We slow down, we ask questions, we hedge our claims. The model doesn't feel that social pressure, so it can confidently deliver something that, in a human conversation, would usually come with warning signs. This is why people get fooled. The grammar is perfect. The explanation flows logically. It uses expert language. It gives steps, examples, and conclusions. So it feels like a teacher. But the logic can be fake. The structure can be polished even when the foundation is wrong. It can explain something beautifully and still be inaccurate because it's optimizing for coherence, not truth. That's why sounds right is not a reliable test anymore. We used to judge quality by how clear and confident something is. But with these systems, clarity is cheap, confidence is cheap. So what should you trust instead? Not the tone, not the speed, not the smoothness. Trust things that can be checked. Specific sources, consistent numbers, verifiable claims, and answers that survive a second opinion. Because if you treat confidence as proof, you'll get tricked. Not because the model is evil, but because it's doing what it was designed to do, generate a convincing answer. So when does it sound right while being wrong most often? There are a few situations where you should be extra careful because the model is basically forced to guess. First, when your question is vague. If you don't give enough context, it fills the gaps. Small gaps are fine, but big gaps create big assumptions. And once the first assumption is wrong, the rest of the answer can be a perfectly written explanation built on the wrong starting point. Second, when you ask for very specific details, exact dates, exact quotes, exact statistics, exact laws, exact top 10 lists, these are the kinds of things that look easy but require real verification. If the model doesn't have a strong anchor, it may invent details that sound realistic. Third, when the topic changes fast, news, prices, policies, product features, rules, and anything time-sensitive. Without a live source, it can't guarantee freshness, so it might give you a confident answer that is simply outdated. Fourth, when you push it into a confident format. If you ask, "Give me the definitive answer," or "Be 100% certain," you're basically telling it to sound decisive. It will often do that, even if it shouldn't. And fifth, when the topic depends on personal context, your country, your company, your specific situation. If the model doesn't know those details, it may assume them. The good news is that these aren't random problems, they're predictable, and once you know the triggers, you can design your prompts to avoid them. In the next scene, I'll give you a simple set of prompt upgrades that reduce these mistakes fast, without turning every question into a long research project. Here are 3 simple prompt upgrades that reduce sounds right but wrong answers fast. You don't need complicated prompt engineering. You just need to force the model to be more transparent. Upgrade number 1. Ask for assumptions. Add one line like, "List the assumptions you're making." This is powerful because most wrong answers come from hidden assumptions. Wrong country, wrong time frame, wrong definitions, or missing context. When the assumptions are visible, you can correct them instantly. Upgrade number 2, demand uncertainty. Say, "If you're not sure, say you're not sure," or give a confidence level and explain why. This doesn't magically make it perfect, but it reduces the confident tone that makes people trust weak answers. It also encourages the model to show where the uncertainty is. Upgrade number 3, require verification steps. Ask, "How can I verify this in 2 minutes?" Or, "Give me 2 reliable sources and quote the exact line that supports the claim." If the model can't provide a realistic verification path, treat the claim as unconfirmed. Now, here's the key. You don't have to do all 3 every time. Use them when the answer matters. For low-stakes tasks, rewriting text, brainstorming ideas, summarizing, just enjoy the speed. But for anything factual, time-sensitive, or high-impact, these upgrades keep you in control. And there's a bonus trick that works surprisingly well. Ask it to argue against itself. Say, "What's the strongest reason your answer could be wrong?" If it produces a strong counterpoint, you've just saved yourself from trusting a weak answer. Next, I'll show you a simple verification workflow, what to check, what to ignore, and how to do it quickly without wasting time. Let's make this practical. Here's a fast workflow that turns a sounds right answer into something you can actually trust without wasting your whole day. Step 1. Identify the load-bearing claims. Every answer has a few statements that carry the entire conclusion. If those statements are wrong, the whole answer collapses. So don't verify every sentence. Verify the 2 or 3 claims that matter most. Step 2. Separate facts from explanations. Ask the model. List the factual claims first, then the reasoning. This makes checking easier because you can focus on claims that can be proven or disproven. Step 3. Cross-check with one reliable source. If it's a statistic, look for the original report. If it's a quote, Find the exact reference. If it's a policy, check the official page. You're not trying to prove the model wrong. You're trying to confirm the key parts that make the answer useful. Step 4. Ask for a second angle, not a second opinion from the same model, but an alternative explanation or a counterargument. You can say, "What's the strongest counterpoint?" or "What's another explanation that fits the facts?" If the answer can't survive a simple challenge, treat it as weak. And here's a simple rule that saves people from a lot of mistakes. The higher the consequences, the higher the verification. If it affects money, health, legal risk, or safety, you don't accept a confident paragraph, you demand proof. This workflow keeps the tool fast and useful while keeping you in control of reality. In the last scene, I'll give you a simple mental checklist you can use every time, so you can spot a sounds right answer in seconds. Before we end, here's a simple checklist you can keep in your head. It helps you spot sounds right answers in seconds. First question, is the answer giving specific details without proof? Exact dates, names, statistics, or quotes are a red flag if there's no source or no way to check them quickly. If it's specific, it should be verifiable. Second question, did it state assumptions? If the answer depends on a country, a time frame, a company rule, or a personal situation, and none of that was clarified, then the answer might be built on the wrong foundation. Third question, is it too clean? That sounds weird, but it's real. Sometimes the structure is perfect, headings, bullet points, confident conclusion, but the substance is vague. A perfect format can hide weak grounding. Don't let structure trick you. Fourth question, can you test it? A good answer usually gives you a path to verification, a source to open, a step to run, a definition to match, or a simple check you can do. If there's no verification path, treat it like a hypothesis. And finally, does it survive a challenge? Ask for the strongest counterargument or the biggest way it could be wrong. If it collapses immediately, you've learned something important. Here's the mindset shift. Treat the first output as version 0. Then your next prompt upgrades it. Assumptions, uncertainty, and verification steps. That second prompt is where the real value appears. So yes, these tools can sound right even when they're wrong. But when you use them correctly, they become incredibly powerful. You get clarity, structure, and speed, while you stay responsible for what's true. If you've ever been fooled by a perfect answer, you're not alone. Let me know in the comments, what's the most confident wrong answer you've seen? If you enjoyed this topic and want more videos like this, make sure to subscribe. If the video helped you, you can leave a like. If not, you can dislike it. I'll survive. Thanks for watching.